This is a problem which we have to solve using the principle of virtual work. If we'll see the problem, it is given that this is our system which is having two link, one piston, one block, and we are applying a force of 100 Newton at this end, and because of this 100 Newton force, system will have certain force transmission, and that force transmission ultimately going to compress this block, and the compression we have to calculate. So in case of virtual work, there are certain requirements which we should follow initially so that the problem becomes easy, and I will explain you step by step that in the given problem, if you want to solve this problem using the principle of virtual work, first you should know the degree of freedom of your system. Normally in first year engineering course, in mechanics, the degree of freedom is 1. Here also if you will see, you can see that if you will give any of motion to any of the point, all other point will automatically get a fixed configuration. What does it mean? It means that if I will take this point and try to move the point in the upward direction, the whole system will try to rotate in this way, or the piston will comes down. Or the other hand, if I will try to rotate the bar in the downward direction, this piston will go in the upward direction. That means all the motions are connected to each other, and therefore the system has only 1 degree of freedom. After understanding the degree of freedom, when you apply the principle of virtual work, your second and immediate job is to make the free body diagram of your system. Here I am making a free body diagram considering the lines. These are the basically this is your first fulcrum part which is pinned at this point. This is your second link, and there is a force of W because of the compression of this block. I am not making the piston and other things. This is your W and this is your force P. Now this is your link 1 and this is your link 2. Both are having angle theta at this stage, and system is in static equilibrium condition. Please remember, whenever you are having a problem of virtual work, the system will be in the static equilibrium and you have to find one of the unknown in your system. Generally we don't solve the problem of dynamics, which is beyond the scope of first year engineering mechanics course. So in this case, after making the line diagram, you have to give a virtual displacement to your system. Please understand what do you mean by virtual displacement. Virtual displacement means you are giving a small variation to your system. Variation in terms of motion. Motion means I will try to give a virtual motion to this point. But when I will give the virtual displacement to this point, as the system has all the links are interconnected and system degree of freedoms are connected to each other, there is a fixed motion to this point. That means the fixed motion to all other points. On the other hand, if I will give any rotation or motion to this point, by default this point will go upward or downward based on the direction of the motion. For example, if I will give an upward rotation to this link, a very small rotation but an upward rotation, so because of this rotation what will happen, this link will get this position, and then the second link, which is this one, will move and come here. So my point of interest, which is having a load W, will come down with certain amount. Suppose I am giving a small rotation and defining that small rotation by del theta. This symbol is del, and del represent the variation in your system. And from the mathematics, it has been observed that this variation is equivalent to the first derivative. So if you want to find any change, you have to differentiate your coordinate. What do you mean by that? Suppose I am interested to find this variation. This is del y. How I can find the variation of this point? Because of the virtual displacement. So for that, what you need to do, first you write the coordinate of this point, and please remember that we always write the coordinate with respect to the constraint point or fixed point. In this case, when I am giving a virtual displacement, this point is not going anywhere. This is a pin joint, and we have to follow the system constraint. We cannot give any kind of virtual displacement. I cannot move this point anywhere. I have to obey the degree of freedom of my system. If my system is allowing the piston to move only in the upward and downward direction, that means this point can only move in the upward or downward direction. This point is a fixed point or a pin point. That means after or before the virtual displacement, it should not move. Only the link or this fulcrum can rotate about this point. So I have given a rotation to this, and because of this rotation, this link has moved by an amount of del theta here, and this link also moved with the del theta. Now I know that I am applying a force P here, and because of the virtual displacement this point has moved here. Similarly, there is a weight load W and point has moved to a distance del y. How I can find the del y? I was explaining this, basically this del y. So to find the del y, first you have to find the y coordinate of this point. So your y coordinate will be 200 cos theta, 200 cos theta, it would be 400 cos theta. Similarly, if I am interested to find the motion of this point, I can assume that this motion is purely a vertical displacement because my rotation is very small, and this can be defined if this is 500. So I know that, suppose this is my del y1. So my del y1 will be 500 del theta, and my del y, so this is del y2. Del y2 is 400 cos theta. This is not del y2, this is the coordinate of this point, and as I said you that I am giving a variation to this point, and this variation can be calculated by differentiating this term. So my del y2 will become 400 minus sine theta del theta. This is standard procedure, so you should not worry that how this del theta has appeared here. It is because when you do the differentiation with respect to del or want to find the variation, you have to follow this kind of differentiation. Now after getting the variation in this point, if I will write the work done because of the virtual displacement, so I know that there are two forces which are actively participating in my work done, and the total work done would be P into motion this del y1 and W into this del y2. Now what are the sign of this work? Whether the work is positive or negative, that can be identified very easily. How? We have given a virtual displacement, when because of the virtual displacement this point is moving in the downward direction. At the same time, if I will see the direction of load W or force W, it is also in the downward direction, means the direction of the force and the direction of virtual displacement are same. That means the work done will be positive. How I am giving this positive sign? Because if you will give the basic definition of work done, is F dot D or FD cos theta, where theta is the angle between the displacement and the force. So here the displacement and the force are in the same direction, so my work done, this angle is 0 degree and work done will be positive. On the other hand, if I will see here, the force is acting in the downward direction, however my virtual displacement is in the vertical direction, so this work done will be negative. Now you may think that I have given this virtual displacement. If I would have given a rotation in the downward direction, why this work done will be positive in that case? Definitely. But if this will be positive, the other would be negative, because when you will give the rotation in this sense, this point will basically move in the upward side, and that time the W and this deflection will become negative. So ultimately when you are giving a virtual displacement on the other configuration, only the sign will be interchanged, but actually relative nature of force work done will remain same. So don't worry, you may give the deflection rotation in the downward side or upward side, it will not make any change. After writing the virtual work equation, as we know that this virtual work done, this is a virtual work done, actually it is not there, that means the total virtual work done will be 0. So when I will see this equation, now I have to only find that what is the relation between the del y1 and del y2. Del y1 is already calculated, and that is minus P 500 del theta. Similarly, if I do something in that way that del y2 can be converted into del theta, I will be having equation where del theta can be common out, and I will have an equation which is solvable. And how I can do that? That is very simple. Maybe this configuration change and everything looks very complicated, but let me tell you, the calculation of this value is very simple. Only you need to do, you have to write the coordinate of that point where you are giving a variation. For that, first you make the original configuration. So this is my original configuration which is given in the question. Then this point is already converted into del theta, so no need to worry. What you need to do, only you have to write the coordinate of this point, and we are writing the coordinate with respect to the point which is not going anywhere. in case of virtual work, this step is very critical step, and you have to only keep in mind that you will going to write the coordinate of your point of interest with respect to a fixed point which is not moving, which is a constraint point. In my problem, this is a point which is not going anywhere. If I'll consider this as a reference, it is also moving because of the motion of this point, so I'm not going to consider this point as a reference or any other point. So please remember, every time whenever you are having a problem of virtual work, you should consider the reference point as a point which is not going anywhere. So this is point which is not going, and I know that this is 200, this is 200, and the angle is theta, which will be available to you when you will solve the problem. Here it is given as theta, so I am keeping it as a theta. So my this distance, which coordinate is y2, is 2 into 200 cos theta. So now this is my coordinate of y2, and as I said that I need the variation of y2. Variation of y2 means I have to differentiate this term, and after the differentiation I am getting that minus 400 sine theta del theta. So this is after differentiation, and now I am going to put this value here. So my equation will completely in terms of del theta, and I will be able to get the value of unknown w. But please remember, when I am going to put this value in this equation, I am not going to consider this sine. I am going to only take the absolute value of this y, because already I have decided the sign of these different terms, work terms. So once I have decided that this work done will be positive and this will be negative, I am not going to change the sign. Only I am going to use the absolute value. If I will take the sign again, the philosophy which I have already applied by considering the force direction and the motion direction will fail. So please remember, you are after the differentiation, you are going to use only the absolute value. So when I will put this absolute value in this equation, my equation will become minus p 500 del theta plus w into 400. I am not using this negative sign, sine theta del theta, and that would be 0. So here you can see that now you are able to remove the del theta. In the question, in this question, theta is not given, but please understand there will be only one unknown, either the force of this block or the theta or this p. Any of the three, out of these three, one will be unknown. Here in the question, theta is not given to you, but we are assuming that theta will be given to you if you want to find a numerical value of this w. But in this question, we are going to write the equation using theta as a variable. So in this equation, if I am interested to find the w, my w will be basically p into 500 by 400 into sine theta. This is the value of unknown w, where p is given 100. So ultimately this will go away, and this will be 500 by 4 sine theta, or 125 by sine theta. So please see that I started the problem with giving a virtual displacement. That virtual displacement is a small variation, and as I know that the system has 1 degree of freedom, so either I move this point or rotation to any of the link, all the other point or link will move automatically because they are interconnected. After the giving a virtual displacement, I wrote the total work done, and then I put it 0, and then I calculated these terms in a single variable term, and finally I calculated the unknown value. Thank you.